All right, so we're on 423. That's data day 6. So again, I'm okay with using calculator on this page. The sort of things I'm about to show with like where you're needing to do sums and things like that, you definitely need that shown on here though. Okay, so first problem is Taz is tracking the number of downloads he gets on each song of his new album. He collects the following data. So here's your data set. Determine how the mean will be impacted by removing the value 790 from the data. So we need to know how many pieces of data we have. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which I just told you there. So that means that to find the mean, we have to take the sum of the data and divide by 10. Okay, so basically we have to add all these up. So that's where a calculator comes in handy. Okay, so the sum of these equals 3,900. Okay, so then we're going to divide that by 10. That means the original data set as an average or a mean of 390. Okay, now the outlier will be skewing the data to the right. Okay, therefore, if we remove the outlier 790 from the data set, okay, then we would calculate all of these, right? Sum of those 9, okay, or you could just take that 3,900 minus 790, do the same thing. But overall, it would be finding the sum of the whole new data set minus the 790. So it's 3,900. Okay, divided by 9. Okay, so that's going to be 345.5 repeating. Okay. Now, I would recommend that you do that division. I did say you could use a calculator on this page. That just make sure you know how to get that answer by hand in case there's separate problems asked like that. So in this case, the mean decreased. Okay, so it decreased by that's going to be 44.4 repeating. Okay, again, I anticipate that most of these questions will have a calculator on the SC ready. That's why I'm letting you use one here. Okay, so make sure that you calculated that and got that answer in there correctly. If you didn't get it right the first time, go back and calculate it again to make sure you're entering the calculations correctly. All right, number 2. Mayor tries to go for at least 1 walk per day, keeps track of the total number of walks he takes in the week, and displays the data in the dot plot below. So each dot represents a week. Okay, so this week he did 0, that week he did 5. So that's how many weeks that he walked. Okay, so that's a total of 16 weeks. Where did I get 16? It's how many dots there are. It's how many weeks. Okay, so the mean, in this case, you add them all up. So it's 5, 10, 16, 22, 28, 34, and so on. And when you add all of them up, find the sum, you get 102. Okay, so 102 divided by 16. And I'm actually going to show you this one. All right, so 102. Again, you can use a calculator here, but I'm just wanting to make sure we don't forget how to do this. 16 times 6 is 96. Okay, that's remainder of 6. Bring the 0 down. Okay, so 16 times 3 is 48. Subtract that. You're going to get 12. All right, so then 16 times 7 is 112. Again, how did I get that? Well, you could guess and check in the margin if you needed to. That's an 8. And then 16 times 5 is 80. Okay, so that's going to be 6. So that's going to be 6.375 is the mean of his data. Okay, so now the median of his data, you mark out 1 on either end because you're trying to find the middle number, right? So here, here, there, So here, 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 like so. That means it's between 7 and 7, which is 7. Okay. All right. Now, the mode, the peak of the data that you have the most of, that's going to be 7 also. All right. Now to the next part of the question. So in the next part of the question, he's like, well, that week where I had 0 didn't count because I was sick all week. All right. So we're going to remove that outlier. So your job there on this part, which you do not need me to show you, but you must have on yours, is to recreate his dot plot just without the 0. So don't put the 0 on there, put the rest of the dots on there all the way through, just like the original problem. Okay. Now, what is the mean of the new data set after removing the outlier? Well, that removed just a 0. Therefore, your total amount, your sum, is still the same. So it's 102. But now, instead of dividing it by 16 weeks, we're dividing by 15. All right. That's going to give us 6.8. So again, that's the sum of all of his walking divided by how many weeks. The median of the new data set is still going to be 7. Okay. I can show you why on this original one. So we're going to, this one didn't count for this one, the next one. So now we're going to start here. Mark out 1, mark out 1. This is how you find median, right? Mark out 1, mark out 1, 1, 1, 1, 1. We're trying to get to the middle number. And you can see that the middle number is going to be that one, which is still 7. Okay. All right. Now, so what we're saying here is that that's the median is still going to be 7. So the mean has, you take the 6.8, which is the new mean, 6.800 minus 6.375. Okay, remember to borrow, makes that 10, then 9. 10 minus 5 is 5. 9 minus 7 is 2. Okay, then that's 7 minus 3 is 4. All right. So what happened here is that the mean increased by 0.425 by removing the outlier. Okay, so that means that outlier was actually dragging it down. It was skewed left. So removing the outlier did not change the median, still the same. Okay, did not change. All right. So that's number 2. All right. Number 3. So Zanira is tracking her number of rebounds per game. So this dot plot is going to show her number of rebounds in each game. All right. So here we need to know, first of all, how many games she has. Okay, so she has 20 games. And now I put median on here first for some reason. So we're going to find the median. 1, 1, 1, 1, 1, 1, 1, 1. Notice I'm just, when you're finding the median, you're just finding the middle number. So marking all these out till we get, so it's between there and there. So it's going to be 2. All right. Now, the mean of her rebound data, when you add all of her rebounds up, you get 51. Okay, so 51 divided by 20 games. So you get the sum of the data, then divide by how many there are. And that gives you 2.55. Okay, this is a good example of how an outlier really skews the data. Okay, it's very much skewed right on the mean because you got that one outlier. Okay, now let's suppose we remove the outlier from this data. So we remove the 12. Okay, so the measure of center she should use to analyze her data is going to be the median, because the outlier at 12 skews the mean. That's what we just talked about. So you remove the 12, then the mean would be far more accurate. Okay, so remove the 12 from the data set. The new mean, so it was 51 was the original rebounds. So take away 12, that's 39. We're going to take that 39 divide by how many games that includes. So it just took out one game, so it's 19 games, right? So now our new mean is instead going to be 2.05. And the median is still going to be 2. It didn't change. All right, so removing the value 12 has what influence does it have on centers of measure? So we will notice that the median did not change. The mean will decrease. Okay, so that's number 3. 2 more. Okay, now this next one here, another good example of why this process we're doing here matters. The annual salaries of 10 employees of a small company are shown. What is the mean of the data? Okay, so if you add all those numbers up, you're going to get 1 million. I'll type it in here. So it's going to be 1,345,000. Okay, now we're going to need to divide it by how many people we're dealing with here, which is 10. Okay, which gives us a mean of the data of, okay, this is going to be 134,500. That's the average salary, but that's not really average for this company because it's being skewed by the CEO's salary, right? Okay, so the median of the data, if you line them all up, which you really need to in this case, okay, so 25, 25, 25, 35, etc., right, on up to 1 million, okay? The median of the data is going to be 40,000, okay? I'm going to show you why. So I'm going to type this in like this. Let me get a new text box here. I'm just going to type in the thousands. So there's 25. I see another 25. I see another 25. 1, 2, 3 25s. See a 35. Another 35. 45. Another 45. A 55. Another 55. And then 1,000 thousandths or 1 million. Okay. Now, if we go through here and we do the way we normally would mark them out for median, like this. Okay, to find the median here, we're between 35 and 45. So we need to average those two. So you add those up, then divide by 2. So 35 plus 45 is 80. 80 divided by 2 is 40. Therefore, the median of the data is 40. But remember, we're talking about thousands of dollars here, so 40,000. Now, the mode would be the one that's there the most. That would be the 25,000. All right. And the reason the median is better than doing the mean here is because basically, right, the CEO or the boss, right, salary is outlier skewing the mean. Okay. So that's the answer for this part of number 4. Okay. All right. I need to get rid of all my annotations here. Clear. All drawings. There we go. All right. Now, if the outlier was removed, what would the effect be on the mean? Okay, so if we remove that outlier of 1 million, now we have this. This would be 345,000. And now it's 9 salaries we're dividing it by. So 345,000 divided by 9 is going to be $38,333. Okay, that would be the new mean. Okay, so the mean would obviously decrease by how much? Well, you take that $134,500 that was the previous mean, then subtract the new one, and you would see how much it decreased by. Okay, so that would be $96,167. Okay, please make sure you understand where I got this from. So I took the previous mean, okay, with all 10 of them, Once we took out the outlier, we got a new mean, and then we saw how much it changed by. All right. All right, now problem 5. Josh bowled 4 games with the following scores. His mean score, so when we add these up, right? So we added those up. That's going to equal 851. We need to divide that by 4 because that's how many games he had. So then that's going to give us a mean score of 212.75. Okay, you need to at least do some of these division by hand to make sure you haven't forgotten how to divide. Okay, now the median score here is going to be if you line them up in order. So here's the line up in order. Okay, so 205 means from least to greatest. 205, 212, 214, 220. Okay, now when we find the middle number here, it's going to be halfway between 212 and 214, which I'm guessing you can figure out is 213, okay, because it's halfway between. If you added those up, that would be 426 divided by 2 is 213. Okay, so now, let's say he bowls a perfect 300 the next game. So now the mean is going to be, well, if the sum of the data before was 851 and we add a 300 to it, now his data set is going to have 1151. Now to find the mean, we divide it by how many games he's done now, which is 5. Now his mean is going to be 230.2. Okay. His median would now be, so let's look at our original list. So our original list of games here, where you had, this is the lowest one. So 300 would be the highest one. Then you get rid of that one and that one, leaving the median middle number would be 214. Okay, so the mean score, right, if he bowled that perfect 300 would obviously increase. Okay, and it increases from 212.75 to 230.2. Okay, so the way we're finding this number right here is taking the original mean, which is 230.2 minus, okay, then we're going to subtract the 212.75. Okay, that's going to give us 17.45. All right, and the median score is actually going to increase, but it increased by exactly 1. So you see how that outlier data piece barely moved to the median. Okay. All right, so that's the 423 practice. Remember, you have weekly review 11 this week also, which is a major grade. So make sure you get that turned in as soon as possible as well.